Hey, what's up guys? Welcome back to the channel again here with an exciting standard DSA problem which is longest repeating subsequence. So this problem is frequently asked by companies like Amazon, Microsoft, Google, etc. So make sure you watch this video till the end. Now the problem says that hey, you are given a string str and you have to find the length of longest repeating subsequence such that it can be found twice in the given string. Now, if you are someone who is looking at this kind of problem first time, then the question will come to your mind is what exactly is a subsequence, right? So let me explain it. First of all, I am going to write the string as given in the example, which is AXX, ZXY. Now, a subsequence is basically a sequence of character in a particular order. So let's say I'm following left to right here, right? So a subsequence is basically a sequence of character. I can write AX as one of the possible subsequences, right? After this, I'm also allowed to skip some characters. So I can write AZ or I can write AZY, right? These are the possible subsequences, or I can write some more subsequences as well. But I think that's enough to explain you what exactly is a subsequence, right? Now, let me explain the given example. So for this example, see, according to the problem, we have to look for longest repeating subsequence, right? So I can write one of the subsequence as XX. So XS is a possible subsequence, and now I can see here that I have got the same subsequence again, right? So again I have XX. This means that XX is something which is a repeating subsequence. So I just need to return the length of this subsequence, right? And while returning the length, make sure that it is the longest possible repeating subsequence. So 2 is the output for this example. Now one more thing is mentioned in the problem. It's very obvious, and it says that while looking for possible subsequences in a string, make sure that two subsequences which are equal are not overlapping, right? Are not completely overlapping. This is what I mean. So let me explain with a given example. For this example, let's say I look for a subsequence which is AC, right? After this, I look for the same subsequence again, and I'll say that okay, I have found one repeating subsequence, right? And the length is 2 here. So this is not true. The reason is I'm looking for the same subsequence again, right? So make sure while looking for two subsequences, you don't the indices are not overlapping. This is what this particular means, and I'll simply say that these are not at same place, right? Because AZ both are at same place. Now I hope you have understood the problem well. So let's talk about the solution now. Okay, so here I have written the same example as given in the problem statement, and according to the problem, our task is to look for the longest repeating subsequence, right? And a repeating subsequence is a subsequence which is occurring at least twice in the given string. So this is something which is going to give us an idea. What we can do is we can look for the same subsequence twice in the given string, and once we have found it, then we can say that it's a repeating subsequence, right? So let me write the same string twice. I have got AXX then ZXY. After this, again the same string. And once I have written this, then all I need to do is I need to look for a subsequence which is present in both the string, right? So I can look for this particular subsequence, but while searching for the same subsequence in different string, make sure that you look at different place, right? So you can see that I have got XX in both the string, right? Actually, both string are same, so I can say that I have got the same subsequence in a string twice, right? Twice. So once I have found this subsequence, then I can say that this is something which is a repeating subsequence, right? And one more subsequence possible is this one, right? I have got X here, and then I have got X here as well. So I can say that X is also a repeating subsequence. So this way I have got every possible repeating subsequence in the given string, and after this I can just look for the longest one. So the longest one is this one, right? So I can return 2 as the output because I'm concerned about the length of longest possible substring. Okay, so okay, my bad, it's actually the subsequence, right? Okay, so now one thing that we can figure out is a repeating subsequence is nothing but the same subsequence at different places, right? So I can say that equal subsequence, let me write it, equal subsequence at different places. different places. So this is something which is our desired output. We need to write a function which is going to give us this particular output, right? Once we have written the function which is going to give us this output, then our task is almost done, right? We have got every possible repeating subsequence, and then we just need to look for the longest one. So how we can implement this function? The idea behind this function is we can try out every possible pair of subsequence, and then we can just look for whether they are equal or not, right? Now all we need to look for is how to check for like every possible subsequence. This is the question now. Okay, so here I am going to show you how we can look for every possible subsequences. So I have written one string here, and for this string let's try to find out every possible subsequence, right? Okay, first of all, we need a pointer which is going to point out to every possible character of the given string. After this, we are going to traverse the string. And while traversing, for each character, we have two options. We can either include or do not include the current character in the given like subsequence, right? So let's do it. For the first character, initially we have an empty substring, or I will say subsequence, right? So if we include the current character, then I will have a in the subsequence, right? And after this my pointer is going to point to second place, and similarly if I don't include the current character, then I will have an empty subsequence, and the pointer is going to point to second place, right? After this again I have two possibility. I can either include or don't include. If I include, then I will have am, right? And if I don't include, then I will have like a. And similarly for this, if I include, then I will have m, and if I don't include, then I will have like empty subsequence, right? Now my pointer is pointing to the last element, right? So my pointer is now pointing to the last element here. Similarly here as well. Okay, so this is for this I'm going to change the color, because now I will get every possible subsequence. So for this one I have two possibility again. I can either include the last character or not. So if I include, then I will have amn, and if I don't include, then I will have am, right? Similarly for this a, if I include, then I will have an, and if I don't include, then I will have a single a. For this m, if I include, then I will have mn. If I don't include, then I will have single m, right? And for an empty subsequence, if I include, then I will have n, and if I don't include, then I will have an empty subsequence, right? So this way I am able to get every possible subsequence of the given string. So the count is 8 here, and the actual count is here 2 raised to the power 3, because the length is 3 here, right? So this way I am able to get every possible subsequence, right? Okay, so now this is about a single string, but in the problem we are given two string, right? We have to get every possible like subsequence for the two strings. So let's see how we can do this. First of all, I'm going to remove all these stuff which I have written here, so that I can get some extra space for writing subsequence for the two strings, right? So let me remove it. uh, okay, so now what I'll do is I'll write both these strings, right? So what were the string that I have? String that I have was like, first of all I have axx, then zxy, and the second string is again axx zxy, right? Now till now we have figured out one thing, that finding all these subsequence is nothing but the game of include or don't include, right? So we have four possibility for these two string. Let's say this is str1 and this is str2, right? So like we have in this particular string, we need some pointer, right? So we have a pointer I for this, and we have a pointer j for this, right? Because this pointer is going to point out every possible character. And after this, what we'll do is we'll simply write all the possibilities. So the first possibility is we can include the character from the first string, and we can include the character which is current character from the second string as well. The second possibility is we can include the character from the first string, and we are not going to include the character from the second string, right? After this, we can not include the character from the first string, and we can include the character from the second string. And the fourth possibility is don't include from the first string and don't include from the second string, right? Well, this is not a possibility that we are going to consider, because if we consider this, then this is something which is going to give us an empty possible substring as well, right? So we can handle this particular case in these three cases only. So let me show you how. first of all, we are going to look a step towards the implementation, and at last I'll definitely talk about the fourth condition as well, right? Okay, so now let me show you how we can try to implement this particular approach. Here I have written the same thing that we have figured out, right? We have three possibilities here for both the strings, and we have got this function where this particular I is pointing to every possible character of str1, and this j is pointing to every possible character of str2. After this, we are going to try to write a function which is going to perform the task for us, right? The task was look for every possible repeating subsequence, if you guys remember that particular observation, right? So first is include from both the strings, right? In which case we are include from both the string, this is the question. So after this we will have a second question, which is how to include, right? The first one is when to include. So let's say currently I'm pointing to these two characters, right? And I have got both the characters are equal in the string, right? Current characters are equal. So I can say that this is going to give me equal subsequences, right? Because we have to look for equal subsequences. Let me write the desired output as well. So we have to look for equal subsequences at different places, right? Different places. So you can see that okay, different places. So now I want you to observe one thing here, that if we get two equal character, then these are going to give me equal subsequences, right? So but the only problem is we are going to we are currently pointing at the same place, so we can't include this. But let's say at any point in time my I is pointing to the second character and my j is pointing to the third character. So I can now see that both are equal, right? Both are equal and both are going to give me the equal subsequence. So I can say I can write the condition if my str1 of I is equal to str2 of j, right? And j is not equal to I. Well, once you have written this condition, then you will find out that this is nothing but this particular thing, right? Equal subsequence or equal character at different places. Once I have found this, then I'll say that of out of the equal subsequences that I have, so I have found one character, right? So let's say I have xx as the equal character, equal subsequence. So I have found one character of this particular subsequence. Once I have found one character, then I can increase the length by one. So I can say that I can increase the length by one, right? So my output is 1 plus. Then I can like once I include the character, then I can call the same function for like I plus 1 and j plus 1. So this is for solve I plus 1 and j plus 1. This is nothing but going to like move one step forward. Once I have include the current character, then I'll do I plus 1 j plus 1. This is like including from both the strings, right? So like if I have a string, let's say a b c d, and I'm at this position, right? And if I include the character, then I have to move to the next position, right? I hope you understand this. So including from both basically means I'm going to increase both the pointers. Once this is clear to you, so you just need to write return here, right? So I'm simply going to return 1 plus solve I plus 1 and j plus 1. But what if this condition is not true? Then these two condition are going to play their role, right? We have two condition then. These are going to give me every possible substring. So what I'll do is I'll simply write a equals to solve for what is this condition. This condition is include from the like current string, include from string 1 and don't include from string 2. So include from string 1 basically means I'm going to do I plus 1, and don't include from string 2 basically means I'm going to remain at same index, right? After this, what is b? B basically means that solve for this condition, right? Don't include from the first string and include from the second string. This is nothing but just the reverse of the first condition, which is a, right? J like I and j plus 1, right? Once I have got these two values, then these two values are nothing but the length of possible repeating subsequence, right? So once you have found these two values, then you just need to return the max of these two values. Why I'm saying max? Because I want the longest possible repeating subsequence. So I'll just say return max of a and b. Well, this is all you need to do in order to solve the problem. And one more thing is, you can see here that we have got a recursive function, right? We are calling the same function again. So this function must stop at some point in time, right? So what is the point where this function is going to stop? I have to write some base condition for this. The base condition is, what if this I had reached the like index which is out of bound for this string, right? At that point this has to return, this has to stop. Or what if j has reached the end? So there are two possibility. If my I is equal to n, so let's say n is the length of these two strings, because I know both string are actually same, then the length is going to remain same, right? So if I is equal to n or j is equal to n, in that case I have to return. But since this is an integer function, then I have to return some value. What is that value? That value is nothing but 0, right? Why 0? Because let's say I have a string abc and the second string is an empty string, right? So for this, what is the longest repeating subsequence? Let me ask from you. Then you will say that it's 0, right? So I have to return 0 in both the cases. Either this is the possibility, or I have an empty string first and then abc. Both means the same, right? Both are going to give us the 0 length for a longest repeating subsequence. Well, this is all about the recursive code. You can see that I have got the recursive approach here, right? And one interesting thing to observe in this approach is the time complexity. So the time complexity is a lot here, and it is going to give us time limit exceed error. So the time complexity, if we calculate, is going to be of 2 raised to the power n, because we are basically trying out every possible like subsequence here, right? So now I hope you have understood the recursive approach. So we can talk about the optimization that we can do in this approach, right? Okay, so now before I talk about the optimal approach, let me talk about the condition that I was ignoring at that time, right? So the condition was do not include from the string 1 and do not include the current character from the string 2, right? So if I see here, then I'll find that do not include basically means that not incrementing the current pointer. So do not include from both the string basically means that I'm not going to increment any of the pointers out of I and j, right? So when I call the function for I and j, this way I'm not incrementing any of the pointers, right? And I'm never going to reach the base case here. And if I don't reach the base case, this basically means that I'm calling the same function infinite times, right? And this is going to give us the stack overflow error. So that's why I was ignoring that particular condition. And the second reason is I can get the same like output, or I can traverse all the possibilities using these two function calls only, right? So that's why it is a kind of irrelevant call that I was ignoring. Now I hope you have understood this particular thing as well. So let me talk about the optimization. First thing that we can notice from the recursive approach is we have this recursive function call, right? This basically means that our solution to main problem is dependent on the solution to sub problems. We are first solving the sub problems, and then we are returning the solution based on these two like value of a and b here, right? So our solution is following the optimal substructure. So I have written the optimal substructure here. The second thing that we can notice is our solution is following overlapping subproblems, but I want to show you. So let's take an example. Let's say for any instance in time, the value of I is 3 and the value of j is 5. So let me show you how the problem is following the overlapping subproblems property, right? So I have 3 and 5, and let's say the value at I is not equal to value at j, right? So for this, I'm simply going to call for I plus 1 and j. This is what I was doing in the recursive approach, then I and j plus 1. So this is going to give me 4 and 5, right? And this is going to give me 3 and 6. After this, again the characters are not equal, so I'll call for 5 and 5, and then here I will call for 4 and 6, right? And here I'll call for 4 and 6, and if the characters are not equal, then I'll call for 3 and 7 here. Okay, now I need to stop at this point, because at this point I have observed one thing. Here I have repetitive subproblems, right? I have already solved this subproblem, and then I'm solving the same problem again. But my question is why? If we have already solved this subproblem, then we can store the solution to this subproblem somewhere in an array, right? And once we have stored in an array, let's say this is ARR. So we can, before solving this problem, we can check whether we have solved it or not. And if we have solved it, then we can simply return the answer from the array, right? And accessing any element from the array is basically O of 1. So instead of doing this subproblem in any complicated time complexity, we can solve the same problem in O of 1 only, right? So this problem is also following overlapping sub problems, right? Okay, now once we have found these two conditions, then we can say that this problem is a dynamic programming problem, right? Because these are the two conditions for dynamic programming. And now let's see how we can solve this problem, because whenever we have found a problem which is based on dynamic programming, then we have two possibilities. Either we can use memoization or we can use tabulation. But let me start with memoization approach. So I have written the same recursive code here, right? And what I can do is, I know my solution is dependent on I and j for every particular like function call, right? So I can store every possible solution. So I can make an array which is dp. I'm writing dp because dp means dynamic programming and it makes more sense here, right? So I can store the solution which is dp of I and j is going to be stored here, right? Similarly, I can store this particular function call as well. Now this is going to store every possible solution in this dp array, right? And now before returning the solution, before returning before solving the problem, I will check whether I have solved the same problems before or not, right? So I'll simply check if solved before, then simply return uh, dp of ij, right? But my question is how to check solve before. So I can initialize this particular dp array with null value or -1 value, right? I'm considering -1 because my solution cannot be negative. So at any point, if the value is not -1 or any positive value, then I can say that the problem is already solved, right? So this is how I can write the memoization approach for the given problem. Now let me show you the memoization code. Okay, so here I have written the memoization code. I have written the C++ code first, and after this I have written the Java code on the right hand side, then followed by Python code, right? So you can see that this code is just an optimization over the recursive code. So you can see that we have recursive code, and then we are just calling, we are first storing the solution, and then we are just checking whether I have already solved the problem or not. So this particular step is a memoization step, right? So I hope you have understood the memoization approach. So now we can talk about the second optimization, which is the tabulation approach. Before we talk about the tabulation approach, let me show you why this is an optimization. So you can see here that memoization is nothing but optimization over recursion, right? So we are still having some recursive call, and when we say recursive call, then it is going to occupy some recursive stack space. So I'm going to occupy some recursive stack space, right? And this is going to increase the space complexity. So the complexity of the problem is now going to reduce to O of n square because of this dp array, and the space complexity of first dp array will use, and then the recursive stack is again going to use O of n square space, right? So this is the what the problem is. We are using some recursive stack space, but we can optimize it. Now let's talk about the tabulation approach. Okay, so let me write tabulation here. I'm simply going to write tabulation here, right? And now for the tabulation, what we can do is, I'm going to take inspiration from the memoization approach in order to write the tabulation approach. So because recursive relation is going to remain same, right? So now let me write this particular condition in form of tabulation. So I can write if my str of I is equal to str of j, and second condition is j is not equal to I. In that case, I can say that my dp of ij is nothing but 1 plus dp of I plus 1 and j, right? Now you can j plus 1. Okay, now you can say that this particular line is nothing but something which is independent of the function call, right? After this I can write the else condition as well in a similar manner. So I'll write dp of I and j is equal to max of dp of I plus 1 and j, and after this I have dp of I and then j plus 1. So now I'm writing code which is something independent of the recursive call. So that's how we are going to optimize the recursive stack space as well, right? So now let me complete this particular thing. I need to write the base condition as well. If my j is equal to n or my I is equal to n, in that case my dp of ij is equal to 0, right? Now the question is, what exactly is this ing, right? So we have to start a loop which is going to store which is going to point to ing. So one important thing is, tabulation is a kind of bottom-up DP approach where we start from base condition and then we move towards the more the solution to the bigger subproblems, right? So what I can do is I can start from the base condition. Base condition is j equals to n, so I can write for I equals to n, and then I is greater than equal to 0, and then I minus minus, right? Similarly, the second loop is for j. j equals to n, then j is greater than equal to 0, then j minus minus. This is how I can get every possibility of I in j, and inside this I can write these particular three condition, right? And this is going to give me the answer. Where I will find the answer? If I move like this, then I will find the answer at the first index. So at last I need to return dp of 0 and 0, right? Now I hope you have understood the tabulation approach as well. Time complexity will be O of n square, because I am not traversing more than n square cells in this particular dp array, and the space complexity is again O of n square and independent of the recursive stack space. So now let me show you the code. Okay, so this is a code for the tabulation approach. On the left hand side, I have written the C++ code. On the right hand side, I have written the Java code, and then followed by the Python code, right? The code is very similar to the one I have explained, right? The only difference is of syntax here. You can see that uh, the code is very similar, like in every possible language if we talk about the approach, right? So this is all about this video. I hope you guys will like the explanation. Thank you.